Good morning. My name is B. Sai Chung. I am from Data Science Department. Today's topic is the effect of video-based tasks in listening comprehension, professional communication subject. Introducing to listening comprehension. Listening comprehension is the cognitive process of decoding auditory input to extract meaning involving phonemic, lexical, and syntactic parsing. It is a critical component of professional communication, especially in real-time techniques, discussions, and collaborative engineering environments. Traditional reasoning tasks rely on audio-only stimuli, but multimodal inputs, example video, enhance conceptual understanding through paralinguistic uses. In computer science and engineering, effective listening supports delegate development, remote collaboration, and requirements election. This study tasks exploit modality effect, auditory narration with visual support, enhances recall by 20 to 30%. Cognitive load is quantified by a past formula CL mental effort into performance by 100, where effort is self-reported and performance test score. This is a good formula. CL equal to mental effort into performance by 100. Objective load is measured using EEG, theta, alpha, band power. In video tasks, extraneous load is reduced through signaling, arrow zooms, and segmenting chunked content for multimedia design principles. NASA TLX Task Load Index provides a multidimensional assessment of mental, physical, and temporal demands in listening tasks. Optimal load occurs when intrinsic content complexity and grammars. Video-based tasks. Video task design framework. Video-based tasks significantly improve listening comprehension by providing authentic language input with visual cause like gestures and facial expressions which aids understanding and retention. Studies show that using videos leads to statistically significant improvements in students' listening skills and also increase their motivation and engagement with the material. How video-based tasks enhance listening comprehension. Authentic input. Video offer a more authentic and complete language input by including nonverbal components that are missing in audio-only materials. Visualize. Visuals like gestures and facial expressions help learners visualize concepts and the context of the conversation, making it easier to grasp the meaning. Increase engagement. The dynamic and interesting nature of video content can increase student motivation and enthusiasm for learning, leading to better learning outcomes. Improved retention. The combination of audio and visual information can help students build stronger mental images, which aids in processing and remembering information. A video task design framework. Video tasks are structured using the ADIE model: analysis, design, development, implementation, and evaluation phases. Key design variables include video length, speech rate, suitable inclusion, and visual cue density. Temporarily continuing principle requires audio and visual stimuli to be synchronized within 200 meters to prevent cognitive dissonance. Signal processing in video-based listening. Audio tracks are pre-processed using noise reduction and voice enhancement. To improve SNR, visual silency maps are computed using little coach models. Identify regions in interest. Example, speaker face diagrams. You can identify speaker face and diagrams. Synchronization is ensured via time-stamped metadata, aligning speech events with visual causes. Eye tracking analysis. Eye tracking matrices, fixation, duration, frequency, quantify attention allocation during video-based listening tasks. High fixation on the speaker's mouth correlates with the phonetic decoding effect, while gaze on visual indicates semantic process. Heat maps and scan paths reveal inefficient attention patterns, guiding video redesigning to align with learning objectives. Neural correlates of comprehension. fMRI studies show video tasks activate the superior temporal gyrus and fusiform gyrus more than audio-only tasks. Increased alpha suppression in facial areas indicates enhanced attention to visual as multimodal tasks. Performances, matrices, and evolution. Comprehension accuracy is measured by standardized tests with video versus audio only conditions. Retention is assessed using delayed recall test with video tasks showing 15 to 25% higher retention rates. The reaction time to comprehension probes is reduced in video task frame rate test due to contextual priming. Signal detection theory the quantifies sensitivity video tasks yielding higher D values indicating improved discrimination of key information. Engineering applications refinements elixation. Video-based listening tasks stimulates client interviews where facial expressions and gestures clarify ambitious requirements. Eye tracing reveals that engineers focus on visual artifacts, diagrams, prototypes more than verbal descriptions, reducing miscommunication. Real-time annotation tools allow practice participants to mock video segments, improving recall of technical constraints. Case study video tasks reduce the requirement errors by 40% in software project. Engineering applications in remote collaboration. Video-based listening enhances virtual team communication by providing non-verbal cues. Example, nodding, pointing, absent audio-only calls. Automated speech to text ASR. Automated speech text ASR with speaker derivation improves accessibility and enables searchable meeting transcripts. Bandwidth optimization ensures video clarity in low connectivity environments. Technical challenges, bandwidth and latency. Video streaming requires 1 to 5 Mbps bandwidth, challenging in rural or mobile environments. Example, drone operations. Okay. Technical challenge, accessibility and inclusivity. Inclusivity. Closed captions must adhere to VCAG 2.1 guidelines. Accuracy less than 99% synchronized with one's is and reliable. Color contents ratio ensure visibility for colorblind users, especially in engineering diagrams. Idea descriptions. In this diagram, you can observe listening, focus on context and purpose on authentic language use. Purpose listeners, sub-skills, communication strategies, focus on comprehension, In this diagram, why video-based learning still matters in 2025. In video-based learning still matters in 2025. In this diagram, we can observe clearly doctor states in digital what patient are listening. Process of listening: the listener hears sounds and focus on them. The listener decodes or encrypts the message. The listener evaluates the message. The listener responds. Process of listening. Conclusion and recommendations. Video-based tasks enhance listening comprehension engineering by leveraging dual coding and reducing conjugate load. This is in conclusion. Thank you.